Hello guys, welcome to the Wireshark Lab number 11. In this lab we are going to see about the 802.11 Wi-Fi. The 802.11 Wi-Fi protocol, what it is? It is a WLAN, the Wireless Local Area Network Protocol. IEEE 802.11 allows wireless and mobile network access to a network infrastructure. Before the 802.11b protocol, which was coined Wi-Fi, was widely adopted in the early 2000s. To get high-speed network access to your LAN, you had to be physically connected via a cable. So in this lab, we will investigate the 802.11 wireless network protocol. In all the Wireshark labs thus far, we have captured frames on a wide Ethernet connection. Here, since 802.11 is a wireless link layer protocol, we will be capturing frames in the air. Unfortunately, some devices we don't have that wireless 802.11 NICs still don't provide the push to capture or receive 802.11 frames for use in workshops. Thus, in this lab, we'll use the traces that are being provided here. If you are able to capture, you can capture, but we have got the traces here. We can download this traces zip file and we will open it. And the next thing, the OC, when we open it, we will see a lot of frames that we are interested in for this lab, such as beacon frames advertised by Nibus AP, also operating on channel 6. The wireless source tag is taken in the trace file. Let's open the trace file first. So you can see you have to open this 802.11. Okay, now you have got the traces here. You can see the beacon frames and it is connected to 30 Monroe ST. Okay, now let's do the practical. As you can see, the host is already associated with the 30 Monroe HT AP when the trace begins. Yes, it is associated with the 30 Monroe HT. We got it. At time 24.82 seconds, the host makes an HTTP request to the HTTP elastics. The IP address of the GIA website is 128.119.245.12. So you can see it is a file. So let's see 24.82. We have to go to the time 24.82. So you can see we have got to the 24.82. We'll open it. Yes, this is just yes. This is, you can see get request Alex Labs elastics. So you can see it is a get request that they are being made. So let's see that what is this now. Now we will see that at time 32.8, so the host makes an HTTP request to csumas.edu whose IP address is 128.119.240.19. So let's trace it. Okay, time 32.82. We are going to see 32.82. Yeah, yeah, you can see here. The host made an get request to www.cs.mouse.edu. So you guys can see it. Now go to the next one. At time 49.58, the host disconnects from the 30 Monroe ST API and attempts to the connect to the link SYS. This is not an open access point, and so the host is eventually unable to connect to this AP. So let's see this error when we try to connect to the another access one. The time mentioned is 49.58. So at the time 49.58. Yeah, you can see the official. So you can see when we are disconnected from the 30 Monroe state and tried to connect an link SYS, we have gotten the de-authentication message. You can see we have got because it is not an open channel, open access channel, so we are not unable to connect it. So we got a de-authentication message. So now when we are able to see 63, the host gives up trying to associate with the link SYS and associate begin with the 30. Okay. So we'll again try to connect with the 30 Mondo state 63 at the time 63. It's try it's fail and it will fail and it's try giving up and we will again connect to the okay let's see yeah you can see it again starts connecting it's giving it given up the connecting to the link SYS. So we have again connected to the 30 Mondo street. You can see prop request to 30 membership. We have de-authentication. Yes, we can see here association request. Yeah, now let's go once you have downloaded the trace. Yeah, we have done it. There's a yes. Next is the beacon frames. Let's recall beacon frames are used by the 802.11 AP to advertise its existence. You can see the question here. What are the SSIDs of the two access points that are issuing most of the beacon frames in this trace? So you can see the SSIDs that is 30 mono ST and the next one is link SYS. So you can see that mostly these are the SIDs that are being in this trace. You can see the question now that is what is the destination MAC address on the beacon frame from 30 Monroe ST? So let's see it. Let's open 30 Monroe ST beacon frame. So you can see the destination address hexadecimal that is broadcast. This is the thing. And next, what is the MAC BBS ID on the beacon frame from 30 Monroe ST? Okay, net MAC BBS ID. You can see MAC BSS ID that is Cisco LIF7 ID 1D51. So in a similar way, you can answer the question. And the third one is the data transfer. Since the trace starts since the trace starts with the host already associated with the AP, let's first look at data transfer over and the 802.11 association before looking at AP association or dissociation. Recall that in the trace at 24.82 time, the host makes an HTTP request to ls.txt. The IP address of gumas.edu is 128.119.245.12. Then at time 32.82, the host makes an HTTP request to this website umas.edu. Now find the 82.11 frame containing the sync TCP segment for the first TCP session that downloads the alias text. What are the MAC address fields in the 802.11 frame? Which MAC address in this frame correspond to the wireless host? So let's see it. So you can see the MAC addresses are here: the receiver address, transmitter address, destination address, source address, and you can also see basis ID. So as mentioned in the questions, you can see like the host connects to the Monroe states again, and this authentication frame sent from the host to the AP and vice versa. So you can see the authentication and the authentication messages, and the authentication requires a key to be open. Yes, you can see the authentication of the Monroe ST, and next the authentication begins for the new link SOS, and it asks for the authentication, which because it's not an open channel, so it requires an authentication, and it requires a key. You can see it requires a key because it is locked, it is not open. So you can see that we have some many acknowledgements, authentications, keys that are being sent from the host, received by the host. So you can see. So thank you.